Kepler's laws of planetary motion. So we know that a great German mathematician and astronomer, Johannes Kepler, established the laws on planetary motion, hence it is named after him, Kepler's laws. In early 17th century, he had given us the laws, but the theory was given by him, but not the motion of the planets. So motion of the planets was given by Newton, and theory for arriving at the motion is given by Kepler. So let's see what are those laws and how it is understood at his time, and later on how it was proved. His law 1 is, his first law is a breakthrough law, because he said each planet revolves around the sun in an elliptical orbit, with the sun at one focus of the ellipse. Ellipse always has two foci, so at one focus of the ellipse, the sun will be there, and the planets revolve around the sun in an elliptical orbit. Why is it breakthrough? Because till then, it was under the impression or an understanding by scientists for 300 years that the planets revolve around the sun in circular orbit, whereas Kepler had given a different meaning, saying that basically the planets move in an elliptical. Elliptical is basically oval, elongated circle which will have two foci, F1 and F2. Let us say the sun is there at F1. Then what will happen to the planets? Let's say, for example, Earth is the planet. It moves in elliptical orbit. This is his first law. Let's see what he talked about in his next law. Let's also understand how his first law was proved. But then they did prove it by using calculus and Newton's inverse square rule. This has been solved, which is F is inversely proportional to R square. So by using those, this law was solved by the scientists, of course. And his second law states the speed of a planet in its orbit varies in such a way that the radius connecting the planet and the sun sweeps over equal areas in equal times. So the planets are moving around, and if we take from F1, the planet is at this position, position A, and the planet is moved from A to B. So the area covered by A, B, F1. And when the planet is at this position, let's say B bar, as it is moving A bar. Now the area is A bar, B bar, F1. Now both of them take equal times to cover this distance. Equal areas AB, F1 is equal to B bar, A bar, F1 in the same time. That is what his law establishes. And it was also solved by using principle of conservation of angular momentum. By using the law of conservation. Since it is angular movements, the motion is angular motion, so we will have angular momentum. So by using the law of conservation and the angular momentum principle, it was proved that it was solved. This particular law has been solved by the scientists later. So what is the third law? The third law states that the squares of the periods of any two planets are in the same ratio as the cubes of their average distances from the Sun. What is the period here? The period of a planet is the time the planet takes to make one complete revolution around the Sun. So the period here is time taken by the planet to make one complete revolution around the Sun. What basically this law states is, there is a relationship between the period and the distance between the objects, between Sun and the planet. So if the distance between the planet and the Sun is d, and the Sun, and TB, the period the planet takes to revolve, then what the third law states is dq is proportional to t square. And it also means if you take two planets, t1 square by t2 square is equal to d1 cube by d2 cube. Squares of the periods of any two planets are in the same ratio as the cubes of their average distances from the Sun. So, if T1 is the period which the planet 1 takes around the Sun, and the distance from the Sun for the planet is D1, then T1 square is proportional to T1 cube. And at the same time, he says it is in the same ratio if you take for the two planets. So this is the Kepler's third law, which has been used for arriving at inverse square rule by Newton. And this also has been solved by using law of mechanics. Law of mechanics are nothing but law of motion. This law also has been solved. So when actually Kepler established the laws, it was not actually solved, but he has established the laws with his observations and studies. But later on, the scientists solved using various mathematical means and laws that have been established later on. And using this particular Kepler's third law, if we know the data of one, let us say one planet is Moon. The other planet we do not know, it is a satellite. If you want to know the data of satellite and Moon data is a known, then we will be able to find out the satellite data using this particular law.